Welcome to my YouTube channel, A Brainery of Civil.
Dear students, today I am going to solve the fifth assignment of fluid mechanics. It is related to the topic of fluid dynamics. Okay, first question. In which of the following measuring devices Bernoulli's equation is used? So first option he has given, it is venturimeter. And the second is orifice meter. So in both these meters, Bernoulli's equation can be used to calculate or to measure rate of flow, or we also call this rate of flow as discharge. Okay, so that is in A and B, Bernoulli's equation can be used. Coming to option 3, it is pitot tube. So in pitot tube, it is used to measure velocity of flow at any point. So this is also based on Bernoulli's equation. Okay, so Bernoulli's equation can be used in venturimeter, in orifice meter, and in pitot tube. So option B for question number 1. Next question. In a closed cylindrical vessel sealed at top and bottom, first of all we will take one closed cylindrical vessel which is sealed at the top, sealed at bottom as well. Now the volume of air before rotation dash the volume of air after rotation. So generally air is one of the fluid. Okay, air can be compressed, but while rotating the cylinder, the air is not going to be compressed. That is, volume of air before rotation is same as the volume of air after rotation. Okay, there is no change in the volume of air. Clear? So option C for question number 2. Next question. A flow has diverging straight streamlines. If the flow is steady, the flow has which type of acceleration? He has given so many options. First of all, we have to study, we have to analyze what are all the different types of accelerations. Okay, so first coming to tangential acceleration. So tangential acceleration means due to change in magnitude. Due to change in magnitude of velocity. In a flow, when there is a change in magnitude of the flow, then that particular flow has tangential acceleration. Generally, streamlines having different spaces. So, space between streamlines changes. Velocity will also changes. So here the conclusion is when the spacing between the streamlines changes, that particular flow has tangential acceleration. Next type of acceleration is normal acceleration. Normal acceleration is developed when there is a change in direction of the flow. Generally, the change in direction will be there when there are curved streamlines. Okay, so for curved streamlines, there is a change in direction. Now coming to, there is another type of acceleration, that is temporal or local acceleration. Temporal acceleration means rate of change of displacement vector with respect to time. So generally u, v, w are displacement vectors along x, y, z direction. So this rate of change of displacement vector along x direction is dou u by dou t, dou v by dou t, dou w by dou t. So these are called temporal local acceleration, temporal or local acceleration, or convective acceleration. So the same rate of change of velocity vector with respect to space. Temporal means with respect to time. Convective means with respect to space. Clear? Now he has given the question as the flow is steady. So the flow is steady means all the parameters. For example, let us consider a particular parameter called velocity of flow. The velocity of flow with respect to time is equal to 0. That is, there is no change in the velocity with respect to time. So when there is no velocity with respect to time, there is no temporal acceleration. Okay, so the flow will have only convective acceleration. Clear? So option B, C, D will have convective acceleration. Now coming to, he has given diverging straight streamlines. So these are diverging straight streamlines. Diverging means the space between the streamlines is going to be increased. That is, there is change in velocity. When there is a change in velocity, you will get tangential acceleration. So finally the conclusion is, the flow has diverging streamlines. That is, tangential acceleration will exist and the flow is steady. Convective acceleration will exist. Convective tangential acceleration will have by this fluid. Clear? Next question. A flow has parallel curved streamlines. Curved streamlines means normal acceleration exists. And the flow is steady means with respect to time. All the parameters are 0. That is, there is no temporal or local velocity, local acceleration. It has convective acceleration. So the flow is having convective normal acceleration. So the answer is D for question number 4. Next question is, the flow in a river during period of heavy rainfall is, that is, when the rainfall is heavy, the river flow like it is unsteady flow. That is, with respect to time, all the parameters are not able to constant. So there will be changes frequently. That is unsteady flow. And with respect to space as well, the parameters are not constant. The flow will become non-uniform. And it is flow in all the directions, not only x, y, z. Even depth of flow will changes rapidly. It is 3-dimensional flow. So unsteady, non-uniform and 3-dimensional. Option D for question number 5. Next question. If the flow is irrotational as well as steady, okay, so then it is known as, so the most basic question you need to know, potential flow means irrotational flow. Potential flow exists only for irrotational flow. Okay, so option C for question number 6. Next question. Moment correction factor beta is used to account for, so it is beta. Beta is moment correction factor. So momentum means mass into velocity. So when there is a correction factor regarding non-uniform distribution of velocity, that non-uniform distribution can be carried by momentum correction factor. So option C for question number 7. Next question. The continuity equation is valid for or not valid for. He has given so many options. Dou u by dou x plus dou v by dou y plus dou w by dou z is equal to 0. So this is the given continuity equation. It is generally applicable for steady and incompressible flow. So coming to options, the option is valid only for fluid flow. This is wrong. Valid for steady, whether compressible or incompressible. This is wrong. Valid for incompressible, it is wrong. We need to check all the options. So that is, it is not valid for unsteady flow. Okay. And incompressible fluids. Okay. So it is valid for incompressible flow, but it is not valid for unsteady flow. Answer A for question number 8. Okay. Next question. Which of the following is an example of free vortex flow? So first of all, we need to know what is a free vortex flow. So free vortex flow is fluid rotating without application of external torque. So that is vortex flow means it is rotating. That is free vortex flow means it is rotating. That is the fluid is rotating without application of external torque. So when there is no application of external torque, angular momentum, that is mvr is equal to 0. Here m is constant. So v is inversely proportional to radius. That is, as we move away from the center, radius increases, velocity decreases. Okay. And he has given a whirlpool that is formed in a river. We are not applying any external torque to form a whirlpool. So it is also called free vortex flow. And flow of liquid through a hole provided at the bottom of a container. We have not provided any external torque, but we just placed one hole at the bottom. Obviously, automatically the fluid will rotating. Option B is also example for free vortex flow. And flow of liquid around a circular bend. We are not applying any external torque, we just provided the bend. Okay, it is also example of free vortex flow. So that is all the given options are examples of free vortex flow. Option D for question number 9. Clear? Next question. The basic definition: velocity potential exists only for, there is a standard statement in the fluid mechanics. It is valid, it is exist only for irrotational flow. Clear? Velocity potential exist only for irrotational flow. Option C for question number 10. Clear? Next question. Yeah, it is a problem, very important. Water is discharging from 50 mm diameter nozzle to a firehouse at 15 liter per second. So first of all, he has given area pi by 4, 50 by 1000 whole square. You will get it is some area, and discharge Q is equal to 15 liters per second. That is 15 by 1000 meter cube per second. We have an equation Q is equal to AV. So Q is 15 by 1000. A is equal to pi by 4 50 by 1000 whole square, and V, velocity at point A, we got VA is equal to 7.65 meter per second. Clear? Now he asked us to calculate x components of force in Newton exerted by on the surface. So Fx is equal to mass flow rate into V1x minus V2x. So V1x is in this direction, V2x is in this direction, that is inlet and outlet. So now, first of all, we can calculate V1x is equal to VA cos 45. That will be 7.65 into cos 45. It is 5.41. And now, to calculate V2x is equal to VC cos 60. So we do not know the value of VC. So he has given the information 1/4 of fluid is along C. As the diameter through the pipe is same, discharge is only 1/4. When the discharge is 1/4, velocity will be reduced by 1/4. That is VC is equal to VA by 4. You need to note this point. 5.41. So divided by 4, it is 7.65. 7.65 divided by 7.65 divided by 4 into cos 45. So it is not 45, it is making an angle 60 degrees. 7.65 divided by 4 into cos 60. So you will get it is 0.956. So put in the formula, Fx is equal to, and you can calculate m dot is equal to mass flow rate. So that is rho into q. Rho is density and q is equal to 15 divided by 1000. So you will get it is 15 kg per second. So 15 V1 is equal to 5.41 minus 0.956. You will get it is 'So the force is 66.81 Newton. So answer for the question number 11 is 66.81 Newton. Okay. Coming to last question. Water in a open channel is held by a sluice gate. Assume the flow at section 1 and 2 incompressible uniform that pressure distribution are hydrostatic. Calculated hydrostatic force. We have a formula. Hydrostatic force Fx is equal to rho into V2 square d2 minus V1 square d1 minus rho g by 2 d1 square minus d2 square. Direct formula. So rho is 1000, V2 is 7 square into d2 is 0.429 minus 1 square into 3 minus 1000 into 9.81 divided by 2, 3 square minus 0.429 square. So you will get it is Fx is equal to minus 25.22 kilonewton per meter. So answer is 25.22 kilonewton per meter. Clear? So this is the last question. And when you are going to face the NPTEL exam, it is required to solve all the assignment solutions. Okay. All the assignment solution links you can find in the description below. Thank you.